In this video, we'll be talking, once again, a little bit more about different ways in which you can use indices for various different trade-offs. Okay, one big distinction to make is a distinction between logical versus physical indices. And I've been playing a little bit fast and loose with these different distinctions, and here I'm going to make the distinction quite clear. So a physical index maps a particular key to a actual address in memory, like a hexadecimal. This is where the object is stored. This is where the value is stored. A physical address is, once again, a real place on the computer. It's often a memory address or a specific location, for instance, on a hard drive or a tape or something like that. A logical index instead maps keys to the primary key of a table. That's actually the type of index that I've been talking more about. So it says, map a particular grade to a particular row ID, or map a particular assignment to a particular student ID. It's mapping a particular key to the primary key of a table. And to actually get the row that you need that actually has the information, use the primary key to get the physical address using the primary index. So the primary index, kind of by definition, must always be physical, because that's how you get from the primary key to the real data itself. All right, so when would you be better to have a logical index versus a physical index? Well, physical indexes are faster, right? You can just say, okay, if I'm trying to find the physical index on grade, I would say, okay, I found the key is 2.7, and the person who has the grade of 2.7 is stored at this memory address. So I just need to do one more lookup, and there I have it. However, the big downside of physical addresses is that if you ever have insertion or deletion, the physical indexes will change. If I add a new value to the data structure, there's a chance that the location in memory where this row is stored is now changed, and it means that all of your physical indices must also be updated because they're pointing at a real place in memory. If the thing they're pointing at moves, they have to change their pointer as well. However, the nice thing is changes to physical addresses don't affect logical indices, because if I just say, hey, the student who has the grade 2.7 points at, the student ID Nahum Joss, even if that row Nahum Joss moves around, it still has the same physical key, so it can still be looked up by its primary key. So that's not a problem. So, index card question. Which is the fastest? So we have a particular table called students. It has a first name, last name, and grade. It has a primary key of first name and last name. I want to know which of these indices are fastest. All right, so this is actually a relatively difficult question. And to be perfectly correct, the best answer here is probably 4 here. It depends on the query and how it's using the index. In general, the primary index is a physical index on the actual data as it's ordered. So in almost every case, the primary index is the fastest way to access your data. However, a physical index on grade could be just as fast depending on exactly how your computer is structured and so forth, which basically allows you to go from each grade to each position in memory. However, a logical index on, say, first name in general it will be slower because it will involve more memory lookups, but because of things like caching and things like that, it's never actually clear exactly what would always be faster. Best way to do any of these sorts of optimizations is through profile and test. But in general, primary physical indices are the fastest, other physical indices are in the next tier, and logical indices are the slowest of the lot. But that doesn't mean that logical indices are the worst, because logical indices don't require nearly as much change if your table changes. All right. Another important thing to think about when you're working with indices is, well, how do you choose the appropriate primary key? So most database management software, including SQLite, order the physical placement of rows in memory according to the primary key. Once again, for SQLite, if you don't specify it, it makes its own primary key called row ID. And so it means that queries that use the primary key are very fast. But if the queries generally are using other attributes, non-primary key attributes, those queries generally will be slower consequently. And so the biggest consideration for what primary key attributes you should be using is primarily caring about what are the most common / most important queries that need to be performed. So you need to think about, okay, is it really common that I'm going to be looking up blog posts by date? And so really, date is probably a much better primary key than like the name of the blog post or something like that. All right, another thing to think about are key constraints. So I've been talking about indices primarily with respect to select statements. And to be honest, that's primarily where indices are used. But another very important use case for indices are key constraints. So what is a constraint again? These are basically rules on what data you're allowed to have in your database. For instance, I can specify foreign key constraints, or I can specify that a particular column must not be null, it must be unique, and it must be an integer. And so how do I check to make sure that I don't have duplicates? Well, the easiest way to check for duplicates is to have an index on the particular column that's under the constraint, so that it's very easy to do a lookup to say, hey, if I have an index, it's very easy to find. Do I have a duplicate? If I don't have an index, I have to check every row in my table to make sure there's no duplicate there. So if you have key constraints, generally the database management software will create a super secret index that it doesn't tell you about anyway to enforce that. But it's often useful to be very explicit and to say, hey, make a key on this, and then so the database management software will be able to use that index instead of having to regenerate it as needed, or maybe regenerate it at a time when you wish it was really spending its time on other things.